All right, so we're going to talk about transformations of quadratics today. We of course remember our general function for transformations where we have the a, k, c, and d values. Remember, of course, that the f part of this is really just f at x, and it refers to whatever parent function we are trying to transform. So in our lesson that we were just finishing up from yesterday, our parent functions were just like the functions that were pre-graphed for us. Today we're going to talk about exclusively using the parent function x squared and how we can perform transformations to that specific thing. We also want to remember, as we are doing the k value, sorry, give me 1 second, guys. Okay, so we're going to, did I play this? Yes, I did, okay. So we're going to just remember with the k value, we always want to use the reciprocal of the k value when we're actually calculating the transformations, and also when we state the transformations in words. No problem. I haven't. Yes, actually. Okay, so when calculating transformations and also writing transformations in words. And the other point here is the k value. If you notice here, the k value is actually outside this set of brackets with the x minus d. So we always must make sure that that k value is common factored out from the x and the d. So that's that's the other thing that we want to make sure with the k value. So make sure it's common factored out from x and d. If it's not, you have to common factor it out yourself. Kylie's question? It has to be common factored out, even if you can't, just like in completing the square, when we take it out from both of those, whether or not it actually is able to be common factored or not, it has to be taken out. So, well, if it's just 3x and there's no d, then it doesn't, yeah, you can just leave it in that case, that's fine. But if there's the two terms, like if there's the x and the d, the k has to be taken out from those. Okay, so we're going to perform transformations on the most basic quadratic that we can have. You guys have graphed this twice now so far. You graphed it in your package and you also graphed it in our lesson from yesterday. We're going to look for changes to the x or horizontal changes, so the k and the d. And we're going to look for our changes to the y or vertical changes. And those are the a and c changes. Okay, so are we all good with this? Can I slide over to the next slide? Yes, no? See some people still rating. Okay. All right, so if you recall, when I have the function, when I have the function x squared, my main key points that we talked about were choosing the x's that just give us a good spread of points on the quadratic. I want some on the left side of the vertex, and I also want some on the right side of the vertex. So we decided that some negative ones as well as 0 and a couple positive ones were giving us a good graph of our quadratic here. And then I just square them to get my y's. So as long as you remember the x's that we use, you can always get the y's by just squaring them like the function tells us to. So 4, 1, 0, 1, and 4. So these are kind of what we're using in our whole lesson today. So in the lesson that we just finished up from yesterday, we had some pre-graphed functions where we located some key points on those, and then those were the points that we used to transform. These are kind of like the key points that will transform for this specific parent function. Okay, and then just a reminder that your order of transformations matters. So we talked about how we have to do all stretches, compressions, and flips first, so the A and K transformations, and then we do the shifts last. Now, the way that I'm going to teach you to do this, it takes care of all of that for you, which is awesome. But we should still remember that A and K come first because they are stretches, compressions, and flips. They're multiplications. And then D and C come last. They are shifts. So shifts are always last. Okay, so Joey, you asked me how you come up with those equations. So this is actually when we go to do like a table of values and we go to like calculate our new points, what we'll end up doing is so of course the left side is for the x's and the right side is for the y's. A and C are changes to the y's. So how we can kind of develop those equations, a general skeleton that you can use is we'll take our y's and we'll multiply them by whatever the a value is, and then we'll add or subtract whatever the c value is. Okay, and then for the x's, these ones are a little bit different. We can't just do kx plus d because the k and the d are kind of like different than how they look in the equation. So what we do is we use the reciprocal of k and we multiply that by x. So whatever the k value is as it appears in the equation, we do the reciprocal, and then we add the d, keeping in mind that the d value is opposite of how it looks in the equation. So this will look different. Remember that we want to remember looks opposite in the equation. So remembering that we want to switch the sign of the d value that we see in the equation. Okay, and then reciprocal is what we want to use for k. So that is essentially what you can use to develop those little equations that Joey was asking me about when we go to calculate our new points. Katie's just staring at me like this. She's like, good? Okay. So we are going to write the new transformed equation. So we're actually going to take our parent function here and show what this would look like with these specific transformations inside of that parent function. So what we do is the f at x is representing that parent function. So we're just going to merge those two functions together and show what it would look like. So the 2 for number 1, what is this value? A, K, D, C? It's an A, it's outside, it's not in the brackets. So our final function, when I combine this with my parent function up here of x squared, it will just look like this, 2x squared. So that would be the actual transformed equation. Okay, this one right here, so this is an A. What is this one in part 2? This one's a k. So this one should be, remember the k and the d are included in whatever the parent function does. So here the main operation of our parent function is to take the x value and square it. K and d will always be inside that squared part. So if I have a k value, it actually looks kind of similar to what we have here, except we want it being squared as well. And that's how we know the difference between an a value versus a k value, right? The a value is outside, whereas the k value is inside with the x. And whatever parent function, whatever operation the parent function performs, we want the k and the d to be inside with it. So that's our equation. Okay, this guy, C or D? C, right? It's not in the brackets. So I should have, for my final equation here, x squared plus 4. It's not inside with the squared. Whereas this guy here, this is a D, it's inside the brackets. So I know that this D should be inside with the squared. So this will be x plus 3 all squared. Yes. You don't have to memorize it. By the time we get to the end of the unit, you'll have done it so many times that you'll know how to do it, right? Okay, A or K? This is an A, so it should be on the outside, not being part of the squared, right? So this is negative x squared, whereas this one, this is a K, so we have to make sure we square that part as well. So it'll be like negative x all squared. Okay, remember that the squared only applies to what's directly in front of it. So if I don't have brackets around it, that's not included in the squared, whereas if I do have brackets around the whole thing, it gets included in the squared. Okay, so we're always going to be labeling our graphs with the final transformed equation like these. Any questions for these 6? Okay, we're going to get to transformations pretty soon. I want to one more time describe transformations in words, and we're going to write out the transformed equation. So we're going to do what we did over here, but there's a few more transformations here. So we have an A, we have a K, we have a D, and we have a C. We should be really good at this point at writing out these transformations and making sure that we're doing them in order. Remember, we talked about doing them, just working your way left to right in the equation as you write your transformations. So A is -2. Can someone tell me what this does? Vertical flip or reflection. That's the negative part. Yep. Yep. And yes, vertical stretch by 2. Good. Okay. K, remember we don't use the reciprocal of K until we have started calculating or started writing the transformation. So what does the negative part of K do to our function? Horizontal reflection, good, that's the negative part. What does the 3 part do? Yep, you're right, horizontal compression by a factor of, what would we use? 1/3, very good, we use the reciprocal. Awesome. Okay, when I state the D value, I need to remember to switch the sign of that D value. So D is -3. And this is a shift left 3 units. And C value shift down 1 unit. And this is also asking us to write the final transformed equation if my parent function is x squared. So this is actually pretty straightforward. What we do, guys, is we drop this f part right here because the f part is representing the parent function, and then those brackets right there will get the operation that the parent function has. So I'm just going to put in a little squared here, and I just drop this f out. So the final transformed equation for this one is just a squared on top of all of that. So the k and the d are inside being squared, and the a and the c are on the outside. So that's the final transformed equation there. Okay, and it will change, of course, based on what the parent function is. Here it tells us our parent function is x squared. Any questions? Do we all feel pretty good about identifying AK, DC and writing their transformation at this point? Yeah? Okay. So if you can do that, this is the last little piece of the puzzle. Do you guys feel like you need a quick 2-minute break before we do the graphs? Okay, 2 minutes and then we'll do the graphs. All right, so we've got a parent function. We are going to perform a couple transformations on it. The important thing that we can identify here is what variables do we have out of A, K, C, and D? We have a K and an A. Okay, so we have a change to the Y's and we also have a change to the X's. My parent function key points, which we listed above, these are the points that I am working with to transform. These 5 points. Okay, this question also asks us to graph the parent function, and we're going to get really good at doing this because we're going to do it quite a few times. So we're going to graph the parent function. If you'd like, you can also add in the points for -3 and +3, which are 9 and 9. And then just sketch out that parent function. So our graph should look similar to this when we're done, but it looks like our transformations are we're going to do a vertical flip and a horizontal compression. So it should look like it's flipped upside down and then horizontally compressed. So it should look actually skinnier once we're finished here. So here's my new table of values. Oh, that was really thick for some reason. My new table of values, maybe we'll do it in a different color. Remember, we want to do the reciprocal of k when we're working with it down here. So I want to have, I want to have 1 over kx plus d over here. And then over here, I want to have ay plus c. So what we end up with here, sorry, just making that smaller. What we end up with over on the left-hand side is the reciprocal of k. Since we don't have a d value, it's just the reciprocal of k. So what will be the reciprocal of my k value? 1/2 times x, and then d is just 0, so you can put +0 if you really want to, but I don't think we need to. And then ay plus c, well, there's no c, so it's just a times y. A is -1, so it'll be negative y. So I'm taking the x coordinates on the left, -2, -1, 0, 1, 2, and I'm halving them all. So when I half -2, I get -1. When I half -1, I get -0.5. When I half 0, I get 0. When I half 1, I get 0.5. And when I half 2, I get 1. So all the coordinates on the left, the x coordinates. Now the y coordinates, we're just going to take these and we're going to multiply them all by -1. So 4 becomes -4. And try to keep these coordinates in line with their x coordinates if you can. -1, 0, -1, and -4. So just switching the sign of all of those y coordinates. And these are our new points. So our new points, we can go ahead and graph those. Again, it should look like our graph has been flipped and horizontally compressed. And because parabolas are symmetrical, our new transform graph should also look symmetrical. Okay, so that's a key for this one. We can't have something symmetrical being transformed into something that's not symmetrical. That doesn't make sense. So the same general shape as the original graph, but just maybe transformed a little bit. Okay, so we have something like this. Okay, and we're going to take a step here to label the new graph with its transformed function. So g at x, here I'm taking out this f, and I'm replacing it with a squared on the outside of this bracket. So it will look like this, negative and then 2x squared. So that's what I'm going to label this graph with. So remove the f, and then a squared goes on the outside of that bracket. Questions for this guy? Okay, I'll give everybody just a second to get caught up here. Are we good? Okay, let's go to the next one. So same parent function. We're going to get really good at writing out these points every time. So our parent is f at x equals x squared, same key points. We're going to rewrite them. Will help us remember them. Oops. Okay, what variables do we have here? What transformation? We have a D. I agree with that, but this is a K. A would be out front if we had an A. So we have actually no changes to our Y coordinates here. Our Y coordinates, because there's no A and C, Y coordinates remain the same. So I can just actually recopy out the Y's here. X's, I want to do the reciprocal of K, and I want to switch the sign of the D value. So reciprocal of -1/2. -2, yes. The negative doesn't change. We just reciprocal it. Okay, and then opposite sign of D, we want to do +1 instead of -1. Good, so let's just recopy out our Y's. That one's easy. And then our X's, we're going to multiply them all by -2 and add 1 to them. So take a second and do that before I do it. Joy?
Is it 5, 3, 1, -1, -3?
It is 5, 3, 1, -1, -3. You're right. Very good. Okay, so we are going to graph the parent function and also the transformed function. Okay, mostly we're just graphing the parent function so we can get used to like the points of this function and how to graph it. So I will ask you to do this quite a bit. And then we'll graph the transformed function. Sometimes it's nice to like have a highlighter, and then once you're confident about your transformed function, you just highlight it so that you know that it's the new transformed one. Okay, so we'll graph these points here, 5, 4, 3, 1. Remember, this should be symmetrical when we're finished. 1, 0, that's on the x-axis. -1, 1, and -3, 4. Okay, that looks symmetrical to me. That's pretty good. Very nice. Okay, new transform function. I am dropping the f in this function up here, and I'm putting a squared on the outside of this bracket. Okay, so making sure that that whole thing is in brackets as well. So it'll be -12 x minus 1 all squared. Okay, any questions for that one? Okay, I want you guys to see if you can try the last one, get your points transformed and find your new graph on your own. I'll be around to answer questions and then I'll start putting my solution up in a few minutes. Okay, so just before you go any further, this is what the tops of your transformation functions should look like. So we did reciprocal of k, we got -1/3, switch the sign of the d value, and then ay plus c, that's -2y minus 1. So if you're working from there, we want to make sure that we have those correct, of course. Nicole? I think it's probably good because if you don't, it's going to be hard to check your work. So if only for like looking back sake, you should make the chart. I think it's going to be pretty hard to do all of those transformations and do them in the proper order if you don't do it. But I could be wrong. I don't know. So these are my points. I've graphed my parent function. I'm just going to take a couple extra steps here to make sure that I have this fully graphed now. This one's going to be pretty compressed, so we'll have to try to be accurate with our like decimals here. Okay, so we should get something like this. And then transformed equation, drop the f and put a squared on the bracket, on that whole set of brackets there. So we should have this squared minus 1. Any questions about anything that I did here? How I calculated something, how I got equations? Derek? I did 4 times negative 2, which gave me negative 8, and then I subtracted 1. Anything else? We're all okay with this? Did you guys get the same thing that I got? Good. Okay. So I'll just stop.